Hello, good afternoon. I'm talking from Barcelona. I'm Xavier de Blas. I have been here in your country, in the Philippines, 2 times, but this year it was impossible for me. Then thank you for virtually inviting me to this conference. Sorry for my English. I will try to talk slowly. And thank you to all the people in Faces, especially to Jeffrey. Also, thank you to John Tan. I have seen that he's in the program. And Joanne, who more I have seen, Josephine Reyes, and thank you for all the people who I don't remember now, but they are friends there, and I hope to see them maybe next year. What I want to introduce is a little bit better our new machine, the linear encoder. Is this kind of machine that I'm showing you here. There's one string. This string is long, and it's connected to some weight, some load that you are moving. The string is also connected to string is also connected to the chronojump, that is our machine that we have made for connect to lots of devices. And there's a software. You are seeing me, but you are seeing also my screen, and this is the program of the Faces conference. This is the program now, sorry. And this is the website of our project, chronojump, and this is our new logo we created yesterday. And here we have information of some different things and our products and our idea and lots of documents. As you can see here, there are a lot of documents in creation, validation, and some things for other people being able to produce it, to connect it, or to do lots of things. Then it's a project that has begun in the university. It's still there, but we are selling some stuff, we are producing technologies, and then there's a little bit of business, but so small, because the main purpose is to have something that can be used everywhere. And the money is always a problem, as I'm going to talk during all the conference. Okay, let's see a little bit the software if you don't know. This is our software. It's software chronojump, as I told you before. We are going to open some data. Here is a person who will perform some exercises later. We can do jumps, reactive jumps, runs, intervallic runs, reaction times, and other kind of tests. We can do tests related to encoder, that is what we are talking about today. Here is the capture screen, here's the analyze screen. We have a server in order to share our data. But all this, I think it's done since 2004, 2004. Then it's a lot of years developing this stuff, and there's no need now to talk a lot of this part. What I want to do now is have prepared some videos today of people who is connected to all these technologies. Of course, I'm losing videos. I'm losing people from Taiwan. I'm losing Anna, who has done lots of work. But you will see some people who is behind us. And then at the last of this small conference, you will see a little bit how the software can work and how we can analyze the data. Okay, let's change the video.
Yo estoy grabando.
Tú estás como grabando.
Grabando. Grabando.
Hello again, people from Philippines. We are in an evaluation. I introduce you Gerard. He's a university teacher and coach, and Mario, who is a student of sports science. And we are going to do a usual evaluation of a leg curl. Then, if you want, Mario, can you come with us to the machine? Here we have the leg curl, and you will see how we connect the linear encoder to the machine. Now he will perform with 28 kilo. That is lightweight for him, and he will do it both legs. Sorry. Then Mario, you prepared?
Yeah.
Okay, then please start. As you can see here, we are seeing how it moves only the position. This line is showing only how it goes up and down the line of the encoder. Okay, it's enough, thank you. And now we have here all the data we want of all the repetitions and duration, range, mean speed, max speed, mean power, peak power, and lots of things that you will see later. Now you are going to see the other way of capture. As I told you before, we have two ways of capture. In the future will be both in only one button. And are you prepared, Mario?
Yes.
Just we are going to repeat with the other mode. And here, start please. Here you can see all the concentric and the mean power and the range of movement. Okay. Can you do one really powerful now? Do powerful, power, speed? Okay, yes, you can see here the difference. Okay, thank you. Stop. As you can see in the graph, these were 4 repetitions of the same weight. This is also the same weight, but it has done a speed so high in comparison with the other. When we have been all our years training in the gym, only thinking on the load that we are moving, we are forgetting the speed. And this is really a better way to work because you know the power that this person is executing. Okay, thank you.
Yeah.
Hello again. Let me introduce now Dr. José María Padilles. He's an engineer, mechanical engineer.
No, electronics.
Electronical engineer. He is also coach in athletics and teacher in the public university of Barcelona, Sports Science University. And he has lots of years in working in the measurement, in the evaluation of his athletes. And he was in the beginning and in all the story of working with Carmelo Bosco and all their team, and he participated as engineer in the development. Here he will show you some things that maybe you have written the articles, but it's difficult you have in your hands, no? Like this.
This is the first ergo jump. Was made in Italy in 18. The next was this, and the next was this. The system was used to measure the power of the legs when we were doing jumps, and with these devices it's possible to separate different forms of strength. This is the famous chronojump, and this device is a photocell to connect in chronojump. these devices is the Master Lab. Was designed for to control the inertial systems in astronauts.
In international...
For astronauts that gone to the International Space Station.
okay.
And this is the grandfather of this one. Is the prototype was made in 1991, and it changed to ground. Sorry.
To ground? No, I don't know. Yeah. This start, he's telling English is not his natural language, and he was saying that this started to grow and grow. Okay, and now he's going to show you some things that he has here in his lab. Like, you know, the boards, drawing place, full of formula, and lots of expensive equipment that is bought with different researches that they have won, lots of cameras and different machines, and lots of computers that during the years they are growing also. Every time there's more people taking, and also the nice thing of this lab is that it's open. Lots of people come here, take the things, there's no problem. Also we are working in nice new things like the Raspberry Pi board, that with this thing we will do our future computer. And that's all at this part. Thank you. Hello again. We want to show you some tools that we use really often to measure power. First, contact platform. This is our design, but as you know, there's on the internet there's the instructions, and everybody can build it. And some people in Philippines is actually building it. Then it's cheaper to produce in every country. This is again our linear encoder that we are putting a lot of time in the development now, in order to have a good tool, reliable, and as cheap as possible. This kind of tools, this is a rotary encoder, these rolls, and it's designed to be connected to this machine. This is a yo-yo machine, or this machine that is a conical machine like Versapule. And this kind of machines, they are also so expensive, but in all the countries there's people who are doing by themselves. They are not selling, but they are doing with their own tools, their own hands. Here we can, Yes is showing you another rotary encoder that is convenient for this kind of machines. Also, this can be cheaper, and we are working on connecting to the chronopeak and fixing the software. Here we have also strain gauge. This kind of gauge is for knowing maximal isometrical force you can develop. This is the Master Lab strain gauge. It's a nice product, but so expensive, and we are trying also to do something as cheap as possible and same quality. And also here, as you know, there's a lot of work that can be done by photocells, by vision camera, all this kind of stuff. And it could be nice to start thinking on put cameras and measure with the digital image that comes instead of mechanical instruments. Also here, for example, we have a laser product that can be used for all these kind of measurements. And nowadays they are expensive. This is difficult to produce by yourself, but you can buy it. And they have not the same frame rate, not the same frequency of sampling than the other instruments. but all these will improve between years. Also, we want to, now Jose Maria is showing a high-speed camera, the first or the most useful, most big high-speed camera, the Casio F1, that it was cheap and you can do lots of things with this. This is our aim. We want that, that the technologies that people can use, they are cheap, they are so powerful, and all these years you have to pay a lot of money for simple things. This is a complex thing that you can do lots of things and it's cheap, and for this reason we don't need to work in this area. We need to try to take as much features from here, but this is already done and it's a good job. But in the other areas there's not a good product that can be used abroad. Then all the sports sciences has a little use of technologies because it's so far away from the people and their real money. Okay? Vale. Here we have again Jose Maria Paduyes with Paula, that they will show us how they use the yo-yo machine connected to our encoder. Okay.
He's my son Xavier. He's trying to solve the problems with the rotatory machines. In this machine we have a problem, is the inertial moment. He is studying this problem and trying to solve it.
Well, basically we need to know what amount of force and power we are developing when we use these kind of machines. For that we primarily need to know the inertial moment of these machines. We are trying to imagine this machine like a pendulum, so only knowing the period of the oscillation we can know the inertial momentum. After that we are trying to guess the force that we have with the air, the friction, and this is a more complicated problem, but well, we are studying this kind of things.
Now we are going to show you a little bit how to analyze some data. Then let's open a session. This session is time ago, but it's quite nice for this example. Here we are in the software of the encoder here, and we are going to analyze the data. This person 3, has made some contractions, concentric contractions with 10 kilo and 20, 30 until 70 kilos. We recorded all these automatically, and let's going to see a fast graph of all what is happening. I'm going to maximize the window. Here is processing the graph, and we have it here. There's a lot of information in only one single graph. This in this color, this salmon, is the power. Here the peak power, the moment that there's a maximum power in one concentric contraction. This is the time needed for arriving to the peak power, and this is the range of movement. For example, looking at the range of movement, this is the first contraction, second, third, fourth, 5, 6 until 46. And here is the kilo, 10 kilo, 10 kilo, 20, 20, 70. Some of the numbers here are hidden for being a clear graph. As you can see, with 10 kilo, all this here, this green line is the mean of the different range of movement. With 20 kilo, this line is lower. With 30 kilos lower, but all of them are similar. But here, with 50 kilos, 60 kilos, and 70 kilos, clearly this person in this bench press is doing a movement not so complete. Then there's a problem in the execution. Then we are controlling the execution. In this data, a part of the range of movement, the losing of range of movement, we have the salmon color is the power that is increasing with 20 kilo, increasing with 30 and 40, and here is starting to decrease. Then this is the area where we can show you that with this load, this athlete from 40 to 50 kilo is where he has more power. Then it's a good area for work if you are interested in the power. And here we, in blue, we have the time needed to the peak power. Then this means that with more heavy weight, he needs a lot of time to achieve his maximum power, and with little weight, he needs only few time. You will see this a little bit better in a graph later. Then let's see another graph like this, for example. We take one curve. Here we have the 46 curves of this athlete. We take one, for example, this curve, the 7. We select it, and we are going to see a lot of data. Because this graph will have too much or all the variables. Here is the height of the string that is going up and down. Here it goes up because it's a concentric contraction movement. Here is the time, and this is the string, how it goes up. The derivation of this that comes directly from the encoder gets us the green line. I don't know if you can see because it's so it's not very sharp here in this graph. It goes here and you see the speed how it's increasing. The blue is the force that he's doing, a lot of force in the beginning, less force later, and here we have the power. Here this movement is only with 10 kilo. Then he make a good acceleration, is the magenta line, then acceleration decrease. Speed is high, but then decrease because he is getting a very high speed movement, 3 meters per second, and then he start going down because he goes so fast with 10 kilo like everyone. This is the power he achieved, the maximum power. Here we have the mean power, the mean speed, the maximum speed, the time to max power, and the time to peak power, and the time to max speed. If you compare this graph, where you can see the speed how goes up, 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 and goes down, with this graph, with a graph 70 kilo, for example, this, the 43, concentric contraction, you see a very different graph. He's trying to go up, 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 but he has lots of problems because he's so heavy. He's with 70 kilo. He continue, and here at that moment, look the green line. He goes, he increases acceleration, he increases speed, sorry, and now he goes all the time at the same speed, more or less. And here he makes a little bit of higher acceleration. Here again is the acceleration curve, up, then he goes down all the time without acceleration because this is 0, and here he go a little bit up. Let me show you a little bit how this will be. Is with 10 kilo, I'm here with my bar and I go fast, and then I stop myself for not breaking my arms. But with 70, I have a lot of problems going up, up. It's difficult, it's heavy, and here I push. This is what this person has done. Then here with 70 kilo, for him is too much, and then he can lift it, but he cannot get a lot of power, because power is force multiplied by velocity, by speed, and force is mass, displaced mass, the kilo, multiplied by acceleration. Then what's happening is with 10 kilo we have a lot of speed and acceleration, but we don't have mass. And with 70 kilo we have a lot of mass, but we don't have speed and acceleration. Then with 40 kilo, with 50 kilo, this person is how he performs best. Let's see this graph. We are going to select nothing. We select, for example, this 10 kilo, and this with 40 kilo, and this with 70 kilo. Let's perform this compare graph, and he will prepare the graph for us, and show us this. Here 10 kilo, 40 and 70 kilo. This is the string, how it goes from down to up. In the three are more or less the same, but as you can see here with 70 kilo, he don't go at the same distance than the others. But look what happened with the speed, the green line. He goes so high, 3 meters per second. The speed here is lower, and the speed here is much lower. Also, you can see here the power. The power here, it's 584 watts. Here 755, and here 590. This is more easy to see with this kind of graph. Power load with only these three curves, these three concentric contractions. Here we have the load, 10 kilo, 40 kilo and 70 kilo. And here we have the power, less than 200, more than 400, and between 350 and 400. This is the mean power, not the max power. Here we can also calculate the peak power. But let's see this with all the curves, all the concentric contractions. Let's see it, analyze. And this is what we have. Some contractions with 10 kilo, with 20, with 30, and with 40 and 50 we have seen before is where we can perform more. 60 and 70 kilo, where there's a lot of variability because he has lots of problems. This is normally what trainers want. Trainers want to connect the encoder to some machine to perform a test with every time more load and to find this area. Then they want to try to train in the maximum power area, for example 45 kilo, with this person. Maybe in the initial of the season they will be more in the 50 kilo, and in the competition maybe they will be in the 40 kilo, but this depends on your sport. But of course you have to think, if you are in tennis, if you are in baseball, if you are in table tennis, in soccer, in basketball, you need to move some mass, your body with something, and this mass has to be moved at high speed, and then is when we are talking about power. We can compare, for example, this person in other sessions, in the beginning of the season, 3 months ago, 6 months ago, 2 years ago. We are going to compare now between persons. Let's compare with person 9 that has 73 concentric contractions, and we are going to do the same graph. And you see here in blue person 3 and in light blue person 9. And you see how person 9 has a different curve, that he arrives to his peak power between 55 and 60 kilo is the place where we have more power. A lot different than this person, than the person 3. Then coach now knows which is the load that is good for this person to continue training power. This is the analyze window, the capture window I have shown a little bit before, when you have seen the athlete Mario performing the curls. There's lots of things that has done more than what you are seeing now. There's tables with all the data. You can save the tables, save the graphs, and it's an improving software that in the website with our forums, people start writing on what's better to do. For example, here this is a Spanish forum that is working better than the English forum, but people writing about the data and what problems have with them or what they need to increase or to improve, and we try to answer them and to make these improvements in the software, because now in this year we made 9 versions of the software. For example, I want that you see this. Here I'm Xavi in the announcement of the 1.3.8 version. The first was the 1.3.0 of this year because it's 2013. Then this is the 1.3 is 2013 version 8. And here is the computers that I have at my home. Yes, at my home I have all these things in order to have chronojump working. And for example, the first version has these things that is written here. The next version has these things. In February 6, more things. 9 of February, more things. 21 of February, more improvements, and more improvements, and more and more and more. Sorry, this page is also in English, but I show you in Spanish. Let me go to English forum, and you will see it also. Here, new version. Go up, and here is the same what I showed you before, but all in English, and all the improvements of the different versions. Then, as I showed you before, or as I tried, this is a Leaf software, a Leaf products. We are trying to do lots of things, and sorry for this long video. I would prefer to be there, will be so much better, have fun with all you, make some juice, you have so great juice, and enjoy the weather, and maybe next year we're going to see all you. We have the plan on try to travel more, because it's been 12 years of my life in working in this thing, first alone, now with lots of people, and this thing can grow, and growing is just putting a lot of your time, a lot of your love, a lot of your knowledge, and meeting a lot of people, improve your English, learn 2,000 languages in Philippines, and then I will try to travel more to a lot of countries in order to have a better thing. Then I hope you have enjoyed. See you in the future. Bye bye.